I am going to teach you sequencing with 3 or more number of machines. Here I am having a biscuit factory as an example, where we have 5 products which are given as jobs: Mari, Nice, Milk Bikis, Salt and Sweet, Dollar. For each of these biscuits, the process of the machine is going to be the same. First mixing, followed by shaping, and then baking, and finally packing. The mixing cannot be taken as the third machine, and baking cannot be the first machine. You cannot bake and then mix. So which means for each of these biscuits, the machine order will remain the same. And every biscuit to be completed, it should follow the process of mixing, shaping, baking and packing. Now, this is unlike the 2 machine model, because when you need to do sequence, I think you remember, for the sequence we have the boxes like this. For each job we have boxes, and then we write machine 1, machine 2. But now there are 4 machines. We cannot take 4 machines into this. We should have only 2 machines. So we are going to convert these 4 machines into a 2 machine model. How to convert this into a 2 machine model? There is a rule or algorithm which is called as Johnson's algorithm or Johnson's rule. What Johnson said was, identify the problem with the number of machines, divide the machines into 3: first machine, middle machines and last machine. First machine here is mixing, and the last machine here is packing, and the middle machines are shaping and baking. Take the least time of the first machine. The least time of the first machine is 10. This time, the least time of the first machine should be greater than or equal to the highest time of the middle machines. The highest time of the middle machines, consider shaping as well as baking. The highest time 7, 6, 8, 6, 9, 5, 6, 7, 7, 4 is 9. Which means, as per the Johnson's rule, the least time of first machine should be greater or equal to the highest time of middle machines. The rule is satisfied. If this rule is satisfied, we can convert the 4 machines problem into a 2 machine model. In case the rule is not satisfied, you can use the same rule for the last machine. So, or the least time of last machine should be greater or equal to the highest time of middle machines. Either the first machine or the last machine, any of these 2 machines should have a greater time. If it is not so, you cannot arrive optimal using this technique. You have some other technique, but the problems is limited only to this Johnson's algorithm rule. I am going to stick on with it. Either the first machine or the last machine will definitely have the higher time. So we have got the higher time in the first machine. I am going to proceed to the next step. The next step is, I am going to call machine A and machine B. I am not going to call any more mixing, shaping, baking, packing. For the time being, I am going to call machine A and machine B. Let us take the jobs. Marie, Nice, Milk Bikis, Salt and Sweet, and Dollar. Take these jobs. Machine A is equal to first machine plus middle machines. First machine for Mari is 13 minutes, middle machines is 7 and 6, which means totaling to 26. For Nice, 12 plus 8 plus 6, 26. For Milk Bikis, 11 plus 9 plus 5, 25. For Salt and Sweet, 14 plus 6 plus 7, 27. Dollar, it is 21. And for machine B, the times are the middle machine plus last machine. Middle machines plus last machine, which means 7 plus 6, 13 plus 10, 23. 8 plus 6, 14 plus 10, 24. 9 plus 5 plus 9, which is 23. 6 plus 7 plus 12, 25. 7 plus 4 plus 11, 22. Now we have actually converted the 4 machines to a 2 machine. This can be done for any number of machines. In case I give you a 5 machine model, first machine, machine 1, last machine will be machine 5, which means 2, 3 and 4 will be the middle machines. If I give you a 6 machine problem, machine 1 will be the first machine, machine 6 will be the last machine, 2, 3, 4, 5 will be the middle machines. So any number of machines which is 3 or more than that, you can adopt this Johnson's algorithm. For 2 machines, the earlier model is suffice. Now let us get the sequencing done. 1, 2, 3, 4 and 5. Machine A on the left hand side, machine B on the right hand side. Always prefer machine A first. Now identify the least timing. The least timing belongs to dollar. Step 1, dollar, which means dollar is out. From the remaining, identify the least timing, which is 23. I think, yeah, there are two 23s. 23 for Milk Bikis and 23 for Mari. Please prefer the 23 of Milk Bikis because 23 to 25. When I compare, this time is lesser, which means Milk Bikis. Come over here, this is step 2. Omit Milk Bikis. Next least is Mari, which is 23. Mari. Now left out time is 26, 24, 27, 25. Least timing is 24, which is Nice. Step 4. And automatically the last one is Salt and Sweet. So this is the order in which we are going to produce dollar, dollar, sweet and salt and sweet, Nice, Mari and Milk Bikis. So let us take the jobs. Dollar, Salt and Sweet, Nice, Mari and Milk Bikis. Mixing, shaping, baking, packing and idle time. idle time for mixing, shaping, baking, packing. You might think why I am drawing for all the four, because there are only two machines, machine A and machine B. Machine A and B is done only to find the job sequence. When you do the scheduling, time scheduling, it should be for the four machines, mixing, shaping, baking, packing. So never do it as machine A and machine B, you are completely wrong. Right? Now in, out, in, out, in, out, in, out. Let us start with dollar. Dollar in mixing. Dollar in mixing is 10 minutes. So 0 we start, 10 we finish. So this machine will start its next job at the 10th minute. Salt and sweet is 14, which is 24. So next is 24. Nice is 12. 36. So next we'll start at 36. Mari is 13. 49. Next we'll start at 49. Milk Bikis is 11, which is 60. Now shaping. This output is transferred here. I will start. Shaping for dollar is 7. So 10 plus 7, 17. Now comes the same old step. 17 or 24, whichever is higher. So 24. Salt and sweet is 6, which is 30. 30 or 36, whichever is higher. 36. Nice is 8, which is 44. 44 or 49, whichever is higher. 49. Mari is 7, which is 56 or 60, whichever is high. That is 60. Then Milk Bikis is 9, which is 69. Baking will start at 17. Out time for baking in dollar is 4, which is 21 or 30. We'll take 30. Salt and sweet is 7, 37. 37 or 44. We'll take 44. Nice is 6. 44 plus 6 is 50. 50 or 56, whichever is higher. Mari is 6. 56 plus 6, 62. 62 or 69, whichever is higher. Milk Bikis is 5, which is 74. Now let us come to the last machine, packing. It will start its first operation at 21. Dollar is 11, which is 32. 32 or 37. We'll take 37. Salt and sweet is 12, which is 49. 49 or 50. 50 is high, so write 50. Nice is 10, which is 50 plus 10, 60. 60 or 62, whichever is higher. 62. Mari is 10, which is 72. 72 or 74, whichever is higher. Milk Bikis is 9, which is 83. So we found the total time elapsed. Let us find the idle time for the first machine, mixing. We start at 0, so no idle time. 10 to 10, no time is lost. 24 to 24, no time is lost. 36 to 36, no time is lost. 49 to 49, no time is lost. But 60 to the last time of 83. 23 minutes is idle here. That makes mixing idle time of 23 minutes. Shaping, we start at 10, so in the beginning we have 10 minutes idle time. Then from the first to the second, 17 to 24, 7 minutes idle. 30 to 36, 6 minutes idle. 44 to 49, 5 minutes idle. 56 to 60, 4 minutes idle. Plus 69 to 83, which is 69 plus 4, 73, which is 14, 14 minutes. That makes it 17, 23, 28, 32, 36, 46 minutes of idle time. For baking, we start at 17, so 17 minutes it's idle. Then the next job, it starts at 30, while it finishes the previous job at 21. 21 to 39 minutes it is idle. 37 to 44, 7 minutes it is idle. 50 to 56, 6 minutes it is idle. 62 to 69, 7 minutes it is idle, plus 74 to 83, 9 minutes idle, which means 26, 33, 39, 46, 55. Then packing, initially 21 minutes idle, 32 to 37, 5 minutes idle, 49 to 50, 1 minute idle, 60 to 62, 2 minutes idle, 72 to 74, 2 minutes idle. For the last machine, you need not take that plus 1. 21, 26, 27, 29, 31. So your solution is now ready. Total time elapsed or time taken is equal to 83 minutes. Idle time of mixing is equal to 23 minutes. Idle time of shaping is equal to 46 minutes. Idle time of baking is equal to 55 minutes. And idle time of packing is equal to 31 minutes. Finally, total idle time is equal to 20, 60, 110, 140, 143, 114, 150, 155 minutes. Thank you.